Hello and welcome everyone. So in the last lecture we have seen question number 4 and question number 5. Now let us start with question number 6. So our sixth question is, find all the point of discontinuity of a function f where f is defined by f of x is equals to 2x plus 3 if x less than equals to 2 and 2x minus 3 if x is greater than 2. So here for this function we have to check the continuity for three cases. Points, all the points which are less than 2, then x is equals to 2, and then all the points which are greater than 2. So suppose c is a real number. So let c be real number where c is less than 2. So now we will check the continuity for all the points which are less than 2. We know that f is well defined for all the points which are less than 2. So we can say that f of 2 equals to, first of all, f of x will be 2x plus 3 for all the points which are less than 2. Now f of 2 is equals to, f of c is equals to 2c plus 3, right? Now we have to find the limit of the function with c less than 2. So limit x tends to c f of x is equals to limit x tends to c 2x plus 3 is equals to 2c plus 3. So here you can see that limit x tends to c f of x is equals to f of c for c less than 2. So we can say that the function is continuous at all the points less than 2. Now let us check the continuity at x is equals to 2. So for x is equals to 2, what we have f of 2 is equals to, now at x is equals to 2, our function is 2x plus 3. So 2 in the bracket 2 plus 3 is equals to 4 plus 3 is equals to 7. Now let us find the left limit and right limit. So limit x tends to 2 minus, we have f of x is equals to limit x tends to 2 minus. Now for all the points which are less than 2, we have the function 2x plus 3. So let me write 2x plus 3, which is equals to which is equals to 2 in the bracket 2 plus 3, which is equals to 4 plus 3, which is equals to 7. Now let us find the right limit. So limit x tends to 2 plus f of x is equals to limit x tends to 2 plus. Now for all the points which are greater than 2, we have 2x minus 3. So 2x minus 3. So 2 into 2 minus 3 is equals to 4 minus 3, which is equals to 1. So here you can see that our left limit and our right limit are not equal, right? So we can say that this function is not continuous at x is equals to 2. So just because limit x tends to 2 minus f of x is not equals to limit x tends to 2 plus f of x. Function f is not continuous at x is equals to 2. Now let us check for our third case. So if c greater than 2, then f of c is equals to 2c minus 3, and limit x tends to c f of x equals to limit x tends to c 2x minus 3, which is equals to 2c minus 3. So here also our function is continuous because limit x tends to c f of x is equals to f of c for all the points which are greater than 2. So our function is continuous at all the points which are less than 2. Our function is continuous at all the points which are greater than 2, but our function is not continuous at x is equals to 2. So we can say that x is equals to 2 is point of discontinuity for this function. So x is equals to 2 is point of discontinuity for the function, right? So this is our sixth question. Now let us go for seventh one. So our seventh question is, find the point of discontinuity of f where f is equals to modulus of x plus 3 if x less than equals to minus 3, minus 2x if x is in between minus 3 to 3. Here we can write it like minus 3 to 3 in the open interval. So if x belongs to open interval minus 3 to 3, then it is minus 2x, and if x is greater than or equals to 3, then it is 6x plus 2. So here let us start with the first one. If we have a point which is less than minus 3, so first of all we will check the continuity for all the points which are less than minus 3. So if C is the point which is less than minus 3. So if we have a point which is less than minus 3, then f of c will be, now here observe carefully, our function is modulus of x plus 3. Now all the points which are less than minus 3 are negative. So for negative points or for negative numbers, the function is written like this, minus c plus 3, or you can write 3 minus c. Why? Because from the modulus, we know that from the definition of modulus, it is negative if x is less than 0 and x is positive if x is greater than or equals to 0. This is the definition of modulus function. So from this we can write minus c plus 3. So let us find the limit of this function. Limit x tends to c, we have f of x is equals to limit x tends to c minus x plus 3, because x is less than minus 3, so which is equals to minus c plus 3. So here we can say that the function f is continuous for all the points which are less than minus 3. So you can write it here. The function f is continuous at x less than minus 3. Now let us take another point which is x is equals to 3. So now for x is equals to minus 3, if x is equals to minus 3, we have f of x is equals to minus x plus 3. So f of minus 3 is equals to minus, now we put the value of x here, which is minus 3 plus 3, so which is equals to 3 plus 3, which is equals to 6. So at x is equals to minus 3, f of minus 3 is 6. Now let us find left and right limit. So limit x tends to minus 3 minus that means left limit f of x is equals to limit x tends to 3 minus x plus 3, which is equals to minus 3 plus 3 is equals to 3 plus 3 is equals to 6. Now let us find the right limit. So limit x tends to minus 3 plus f of x, which is equals to limit x tends to minus 3 plus, now what is the function when x is greater than minus 3? So let me check it. So whenever x is greater than minus 3, our function is minus 2x. So let me write it here, minus 2x, which is equals to minus 2 in the bracket minus 3, which is equals to 6. So here we can see that our left limit and our right limit are equal, and which is equals to f of minus 3. So here we can write limit x tends to 3 minus 3 minus f of x is equals to limit x tends to minus 3 plus f of x is equals to f of minus 3. So at x is equals to minus 3, our function is continuous. So f is continuous at x is equals to minus 3. Now let us check for x is equals to, let us check for x which is belongs to minus 3 to 3. That means we have to check for all the points which are belongs to minus 3 and 3. So now if x is belongs to minus 3 to 3, f of x is equals to, here we have to write c. So we have taken a point c which is belongs to minus 3 to 3. Now for a point minus 3 to 3, our function is minus 2x. So we get f of c is equals to minus 2c. Now let us take a limit. So limit x tends to c f of x. Now here our point c is in between minus 3 to 3. So we can write limit x tends to c minus 2x. So is equals to minus 2 into c. So here also we can write that our function is continuous when x is in between minus 3 to 3. So let me write it here. F is continuous at x belongs to minus 3 to 3. Now for x is greater than 3 or x is equals to 3, we have to check the continuity at x is equals to 3 and all the points which are greater than 3. So let us check. So first of all, let us check the continuity for the point x is equals to 3. So now if x is equals to 3, then f of x is equals to, now for x is equals to 3, our function f of x is equals to 6x plus 2. So let me write it here, 6x plus 2. So f of 3 is equals to 6 in the bracket 3 plus 2, which is equals to 18 plus 2, which is equals to 20. Now let us find left limit and right limit of a function. So limit x tends to 3 minus f of x. Now what is our function f of x whenever x is less than 3? So whenever x is less than 3, our function f of x is equals to minus 2x. So here we have to write minus 2x. Limit x tends to 3 minus 2x is equals to minus 2 into 3 is equals to minus 6. Okay, and from here we can say that the function is not continuous at x is equals to 3, but we can find the left limit also. So let me find first left limit and after that we will conclude. So limit x tends to 3 plus, sorry, we have already find the left limit, we have to find right limit. F of x is equals to limit x tends to 3 plus, and what will be our function? It will be 6x plus 2 for all the points which are greater than 3. So is equals to 6 in the bracket 3 plus 2, which is equals to 20. So our function is not continuous at x is equals to 3 because limit x tends to 3 minus f of x is not equal to limit x tends to 3 plus f of x. Therefore, f is not continuous at x is equals to 3. So we can say that point x is equals to 3 is a point of discontinuity, right? Now one more condition we have to check. So for a real number c which is greater than 3, if c is greater than 3, f of x is equals to 6x plus 3 and f of c is equals to 6c plus 3, right? Now limit x tends to c, we get f of x is equals to limit x tends to c 6x plus 3, which is equals to 6c plus, I think it is 2, right? Let me check. Yes, it is 2, 6x plus 2. So let me correct it here and here also. So here it is 6x plus 2, 6x plus 2, 6x plus 2. So 6c plus 2. So here limit x tends to c, f of x is equals to f of c. So we can say that function f is continuous whenever x is greater than, for all the points which are for x is greater than 3. So our point of discontinuity is x is equals to 3. Here we can write, therefore point of discontinuity is x is equals to 3, right? So that's it for today's lecture. Rest of the question we will see in the next class. Goodbye. Take care.